Good morning, good afternoon, good evening, depending on your location. Okay, quickly, remember in our previous video, I said I'll be giving us special. Please take note, this video I'm making is strictly for teachers, chemistry teachers. Students, your own will come later. Please, teachers, chemistry tutors in secondary schools, this video is for you, please. Now, in this video, we'll be looking at how to get the theoretical value of our endpoint that will guide us on what our practical our value will be when we do the practical. Okay, so this is just a guide to see the range of the endpoint for the 2026 WAEC chemistry practical. So teachers, please take note. So we're starting with the acid, and we're provided the acid to be tetraoxosulfate 6 acid, H2SO4. Okay, and it should contain relative density. It has a relative density of about 1.84 grams cm3 per cm3. Okay, and the percentage purity to be, I think, 98%. This is the specification from WAEC. Relative density now 1.84, rather, please. 1.84. The specific gravity is 1.84. Please take note. Or the relative density, while the purity is 98. So let's quickly see how we can derive the theoretical value of our endpoint. Okay, this is just the theoretical values. Please, teachers, take note. Okay, that does not mean you should not do the live practical to obtain your own endpoint as a chemistry teacher. So let's quickly see how we can do that. Let's get the volume of the acid in mole per dm cube. Okay, the concentration of the acid in mole per dm cube, rather. Let's get the concentration of the acid in mole per dm cube, not the volume of the acid, please. This is the concentration of the acid in mole per dm cube, and the formula to use is relative density multiplied by the volume. Remember, in the paper provided by WAEC, they said this volume should be made up to 1000 cm3, which is 1 dm cube. So we're working with this volume multiplied by the volume times the percentage purity, okay, all over the molar mass of the acid. Okay, now see how to get our concentration of the acid. This is a guide on how to get the concentration of the acid in mole per dm cube. Relative density times the volume provided by WAEC times percentage purity all over molar mass of the acid. And the relative density given to us in the paper is 1.84 grams cm3, and percentage purity is 98%. Okay, so quickly, let's get the molar mass of the acid. Okay, we know how to calculate it already. We have 2 multiplied by 1. Sulfur is 32 and oxygen is 16, so 16 times 6. So 22 plus 32 plus, I think, 64 should give us 98 gram per mole. 98 gram per mole is the molar mass. Okay, is the molar mass of the acid. So quickly, let's calculate the concentration. Let's calculate this concentration of the acid in mole per dm cube using this formula. Remember, please, teachers, this is the theoretical value. Okay, this is not the end point value after a titration was done. I'm yet to do the titration, so I advise you as a chemistry teacher as well to do your titration. This will only give you a guide on what you should be expecting or what the endpoint should be like. Okay, so please, teachers, please take note. Remember, students, this is not for you, this is for your chemistry teacher. It's just like a guide. Okay, please, as you're watching this, if you like the what we are feeding you with, please always comment, share, repost. Don't forget to turn on the notification bell to know when next video is dropping. Please do well to subscribe. Thank you. All right, so let's put in our values and see what we have to get the concentration of the acid in mole per dm cube. Okay, we'll have relative density is 1.84 multiplied by 5.60 multiplied by the percentage purity is meant to be 98%. What will it be? That's 0.98. When 0.98 divided by, what do we have as the molar mass of the acid? We calculated it to be 98. So 98. So when we do the calculation, okay, when we do the calculation, we have 1.84 multiplied by 5.6 multiplied by 0.98. Okay, and we'll now divide by 98, which is the molar mass of the acid. So we are left with Ca equals 0.10304. Okay, to 3 significant figure becomes 0.103 mole per dm cube of the acid. Please, this is theoretical value. Now we're also given that the base being sodium hydroxide were to divide or to dissolve 4 gram in 1000 cm cube, which is 1 dm cube. What is dissolve 4 gram in 1000 cm cube, which is 1 dm cube. Okay, so we'll be needing, we'll also get the molarity of this base. How do we do that? So sodium hydroxide is 23 plus 16 plus 1 to give us 40 gram per mole. Okay, to give us 40 gram per mole. So when we do that, we've gotten the molar mass of the base. So how do we get the concentration of the base also in mole per dm cube? How do we get it? It is mass, okay, mass concentration all over molar mass. Okay, are you following? We want to get the concentration of the base in mole per dm cube. Mass concentration over molar mass. When we do that, the mass concentration is 4 and the molar mass is what? 40. So we'll have 40. When you divide, I think we should have 0.100 mole per dm cube. 0.100 mole per dm cube. That will be the concentration of the base. Okay, so next thing to do now is to now get the value of the titer value using the theoretical titer value now using Ca Va over Cb Vb equal to Na over Nb. Now remember, this is how to get, now we'll now look for Va. Whatever Va gives us becomes the theoretical value of the endpoint. Now remember that this involves an acid H2SO4 and it involves a base sodium hydroxide. Okay, so when you balance this equation, you should be expecting Na2SO4 plus water. Okay, this is the balance equation: the acid, the base, the salt, and the water. Now you can see that the number of moles of base is 2 and that of acid is 1. Okay, so we'll come here and make our substitution. Our Ca already, our Ca is 0.103 times Va is what you're looking for, all over 0.100 for the Cb, and Vb, remember the volume of your base is always, for me, I'm using 25. We have two calibrations of the pipette, either 25 or 20 cm cube, but I'm using 25. So check what your school uses. Okay, if your school is using 20, you put 20 here, but I'm using 25. And the number of moles of acid is 1 and that of base is 2. So when you do your multiplication very well with your calculation, okay, you will see that you make Va subject of the formula, and when you make that, you should be having about 12.14 cm cube. 12.14 cm cube. Okay, we'll start afresh. you first of all, to get your concentration of the acid, multiply relative density by the volume provided that you have to divide in 1000 cm cube, multiply by percentage purity over molar mass of the acid. Now you take the molar mass of the acid, you know how to make the calculation, you get 98, and this is the equation of reaction. Okay, you can see 2 moles of the base, 1 mole of the acid. Now when you do your substitution, we arrived at Ca being this value, the molarity of Ca. Now we're told to divide 4 gram in 1000 cm cube, which is 1 dm cube, to get the molarity of the sodium hydroxide. We had to take the molar mass first, and we got 40, and then to get the molarity, you do mass concentration over molar mass. This is the mass in 1 dm cube, molar mass. So when you do that, you have 0.100. Now when you do normal substitution, you already know that number of moles of acid is 1 and that of base is 2. So I did my substitution and my VA becomes this. Please, this is the theoretical values. Teachers, this is a theoretical value to only guide you on the value you should be expecting when you do your life practical. Okay, please like, comment, subscribe, repost, and share. Do have a wonderful day as well. Wait the next video on life practical. Have a nice day. Bye for now.